All right, so we're back to talk about the second part of 3B and get into measurements and specifically now significant digits. Okay, so we talked already about error, accuracy, precision, and now we're going to get into talking about what are significant digits and why we need them. So, the first thing we want to review really quick, which we've done this quite a bit, but we want to talk about what data is. And data, and this is just a quick side fun fact, okay? The singular form of data, data is a plural word, the singular form is actually datum. D-A-T-U-M. So that's a singular piece of data is a datum. So that's just a side note for you. But when we are looking at data, we know we can have quantitative data or we can have qualitative data. And then within quantitative data, remember quantitative has that in, that means number. We can either have measured quantitative data or we have counted quantitative data, okay? Now, if you're counting, all right, and you mess up, okay, so say you're counting the number of students in the room and you get, 21 and really there's 22 students, okay, you made a mistake, okay, but so your accuracy is off. However, there should be no uncertainty as to whether or not you counted the number of students you counted. So there's no way to have, half of a student. All right, so you're not measuring the student to a standard. You're not going to count a half a student. Everybody's either a student or they're not, and you count them or you don't. So there's no uncertainty, or you could say there's infinite precision. Infinite precision for counted numbers. With measurement, however, okay, we have some room for interpretation, okay, or bias. So there's more bias in measured data, okay? There's more room for interpretations. So what we have come up with is the standard way to make sure everybody knows that that bias is there and then knows what to do with it, okay? So my first question for you, I want you to write this question down, and you're going to turn this into me as showing me that you listened to this video. So this first question, there's going to be 3 in this whole video. The first question I want you to write down is, why do scientists use significant digits? Okay, first question. Why do scientists use significant digits? Okay, and the answer is that significant digits help us communicate precision. Okay, they help us communicate precision, and they help us be honest. All right, so they're allowing us to be honest. So when we communicate precision, okay, think about Goldilocks and the 3 bears. All right, these are my bears. Okay. All right. So, you don't want to be too precise or not precise enough. All right. You want to be just right. Okay, so when we're looking at precision, it's not about being too precise or not precise enough. You don't want either one of those. No, neither one of these is ideal. You want it to be just right, the correct amount of precision. Okay. And why is that? Again, oops, wait, back over here. Why is that? We want our data to retain meaning and certainty. Okay, the meaning. Do we agree on what this means, and that's where our unit comes in. And then certainty. How sure are you of that observation? When you tell me that the table is a meter long, is it exactly a meter, or could it be like a meter and a half, or 1.2 meters, or maybe even 0.8 meters? Okay, how sure are you of that measurement? Okay, this is really fundamentally an integrity issue. So it's not just science. We got to do this right. It's integrity, because if you're communicating that a number is more precise than it is or less precise than it is, it's essentially lying. Okay, and we definitely don't want to do that. Okay, so let's talk about what significant digits are and what they help us do. So my second question for you, I want you to write down. This is the second question. You got to write this question down and then write down the answer. Is what do significant digits tell us exactly? So first question was, why do scientists use significant digits? And that's to communicate precision. And then what is it exactly that they tell us? Okay, and here's the answer to that. They tell us all the certain digits, everything we're sure about based on our instrument, plus an estimated digit. Okay, and this process tells us what the precision of our instrument is. So what do significant digits tell us? They tell us the precision of our instrument. Okay, so how many digits you have will depend on what you use to measure. Okay, so if we take a look, excuse me, I have two rulers, and I kind of did an example like this on the fly last time, but I figured I'd do one that looks a little bit nicer. So I have two rulers, and one has lots of little markings. Well, not lots, but it has 10 little markings in between, whereas this one only has the big markings. So the 1, 2, 3 versus the 1.1, 1.2, 1.3, etc. So that's how this would go. 1.3, 1.4, and so on. Okay, so when we measure with each of these rulers, we are going to need to communicate different answers. Okay, so if you're measuring with this ruler up here, the red line is the thing you're measuring, you can see that our red line is between 2.5 and 2.6. You know, because you've got this particular instrument that tells you, okay, that your red line is between 2.5 and 2.6, it would be wrong of you to just say 2, or even to just say 2.5, because you have the precision available to you. You have the ability to see that it's more than just 2 or 2.5. It's actually about halfway between. Now, when you estimate that last digit, you might think, well, actually, it's definitely past 2.5, but I think it's closer to 2.5. So you might have estimated 2.54, or you might have looked at that red line and said, no, actually, I think it's a little bit closer to 2.6. I'm going to say it's 2.56. Okay. Both of those would still be correct, because that last digit that you've got is an estimated digit. That's going to vary. That's going to depend more on the observer, okay, while the number of digits depends on the instrument. Okay, so I'll say that one more time. The number of digits will depend on the instrument, the tool you're using to measure, while that last digit's value, that's going to depend more on the observer, and that's where some bias starts to enter, and that's okay, because we know that it's there. We recognize that that's going to happen. That's why when you're doing measurements in the lab, you really want the same person to measure each time, because more than likely that person is going to lean more towards one way of reading than another. Okay. Now, if we look down at this ruler, okay, all our markings tell us is that the red line is between 2 and 3. Okay, so if I were to report something that was more precise than that, like 2.58935 2, if I said my measurement was that, that is a bold-faced lie. That is absolutely untrue because I don't have the instrument to show me all those markings to get that precise. That is way too precise. Okay, but I can see it's past 2 and it's less than 3. So I would want to go ahead and estimate one more digit, that 5. But again, you might say, it looks a little bit closer to 2 to me, and estimate 2.4. Or even, maybe it's closer to 3. I would estimate 2.6. Those are all reasonable values to estimate. But something like this down here is definitely too precise. Or even something less precise, like just 2 or just 3. Those would be incorrect also, because you know it's definitely not exactly 2 or exactly 3. Okay, so speaking of being exactly 2 or exactly 3, what do we do when our measurement hits the line exactly? So what if we're measuring something and it hits right there? Okay, well then would the answer be 2? Okay, well, sort of. Okay, it is 2. However, we know it's more precise than 2 because we know that our estimated digit would be 0. We still want to include an estimated digit because that's the precision of our instrument. We can communicate to other people that it's not just around 2, it's actually right on 2, and that 0 on the end adds precision. Okay, the 0 on the end adds precision. And in this case, you need that precision in order to be honest. Okay, same thing would happen up here. Actually, up here, if our measurement landed right on the 2, we would actually give 2 digits of zeros. 2.00 would be correct. We'll talk more about how to choose that zeros and know what zeros are significant when we in the next video. Okay, so those are our sort of general guidelines for measuring with an instrument. The last question I'm going to ask you to write down is, what digits get included in significant digits measurements? Okay, what digits get included in significant digits measurements? And the answer is all the certain digits plus one estimated digit. Okay, all the certain digits plus one estimated digit. Okay, so that's the overview. We're going to get into these specific details about how to tell if something's significant or not in the next video. Really quick before I sign off here, I do want to go back and emphasize significant digits only apply to measured data. So if I'm going back up here and I'm talking about counted data, I'm talking about the number of students in the room, and I say 22 again, I'm not there are no significant digits in that number, okay, because I've counted them. That's got infinite precision. Okay, our measured data is the only kind of information that we use significant digits for. Okay, all right, so that'll be it for sort of our conceptual understanding of significant digits. The next video will get into some of the details of how to recognize significant digits.